All right, so we're going to solve these equations. First thing you have to remember is that that minus goes with the 8, so it's really like a plus a negative 8. So we're going to distribute the negative to both of those terms. So I have 1, and then a negative 8 times a negative 8 makes a positive 64, and an 8k. So combine your like terms. And I'm going to add 5k over to this side over here, and I'm going to subtract my 65 over there. So we're going to do 39 minus the 65, and then 8 plus 5, and divide both sides by 13. On here, since you have a number on bottom, it's going to be easiest to multiply both of these sides by the negative 7 to get rid of it. So that will cancel it. So this whole side is going to get multiplied by a negative 7. So we get, now it's just a linear, oh, there's a variable back here. Now it's just a linear equation for us. So I'm going to go ahead and subtract my 4y to this side here, and I'm going to add my 7 over here. So I get 0 equals 38y. And as long as the number in front of the y is not 0, that's fine. Divide both sides by 38, and then you get 0 equals y. So if you plug in 0 back into the original equation, it should come out. You're going to get negative 7 divided by negative 7 is a 1, and then over here you get 1. So 1 equals 1. So that works. Same as over here, I should have said, you can plug the negative 2 back into the original equation to make sure that you didn't mess up. So what that would look like, just to make sure we all understand how to plug numbers back in, so I'm going to multiply this by a negative 2. So I get 49. So now when I plug it into the other side, I better also get out 49. Oopsie. See, so I got 49 again. So that means that our answer was right. So if they were different, then it would tell you that you made a math mistake somewhere. All right. So on this one here, I'm going to multiply both those numbers by 4/3. So I'm going to do 9 times the 4/3 and the negative 51 times the 4/3. So this gives me 12w. I'm going to go ahead and distribute that negative 1 to both of those terms to get rid of my parentheses. Remember that negative really means negative 1. I'm going to combine my two like terms there. Now some of you will see right here, oops, it's a W, that these are the exact same things. But let's say you didn't notice that yet. So we're going to subtract over the 12w. I get negative 68 equals negative 68. At any time when you see that it's the exact same thing, like these are the exact same, it's a true statement. So a true statement means that any number is going to work in here. So we're going to have infinitely many solutions on this one. All right, so down here, I'm going to go ahead and combine these two like terms, a 3x and a minus x. And I'm going to go ahead and multiply in my 3/2 to both of those terms. So I multiply this, I'm going to end up with a 2x. Multiply 12 by that number, and I will get 18. And then there's a plus 17 back here. So we're going to combine these two. So we have 2x plus 11 equals 2x plus 25. That's an untrue statement, so this is going to be a no solution. But if you don't yet notice it's a no solution, you can still minus 2x from both sides. 11 equals 25. That is not a true statement. So that's why this one right here would have no solution. All right, under literal equations, so that just means there's a bunch of variables in it, is what the literal part means. And we're going to be solving for whatever it tells us over here to solve for. So we're trying to get j by itself. So whenever I see one side as a fraction, one side is not, I'm going to go ahead and make them both fractions and cross multiply. So this is going to make 8h equals 18kj. And now it seems a lot easier to get j by itself because we just need to divide both sides by our 18k. So j would equal 8h over 18k, but you should reduce 8 over 18 since they're both divisible by, see if we do 2. So it's going to be, and this right here would be the reduced answer that we would want, the 4h over 9k. All right, here we're trying to solve for B1 right here. So the first thing I see is that I have a half and the h on the outside. So first I'll multiply the 2 over. So instead of dividing by half, remember you multiply by 2. And then I'm going to divide both sides by h. So I have 2a over h. And now the last step to get B1 by itself is to subtract it over. So B1 would equal 2a over h minus the B2 term. Solving this for y. So my first step is to subtract my 3x over. Remember, we're just treating like everything else is a number. That's how I'm able to figure these out. So then I need to divide everything by a 4. So I'm going to just divide each term by 4. So I have like 7/4 z minus 3/4 x. But you could have left it looking like this right here too. That's fine. And then we're going to square root both sides. So y is going to equal plus and minus the square root of 7/4 z minus 3/4 x. All right, so to get m by itself, I have to first get m on the same side of the equal sign or we could never isolate it. So I'm just going to go ahead and subtract that over. So I have negative p equals 2m minus mn. And now since both of these terms have an m in it, I can actually factor it out in front. So divide the m to the front of this. Now it says m times another term, and since it's m times, we can get rid of it. You can't get rid of it when you have a bunch of terms with m until it's isolated. So now to both sides by 2 minus n. Now, if you happen to switch everything around, what your answer would be p over n minus 2. And this is the exact same answer as this because every single term is off by a negative sign. So this answer would be the exact same answer as that one.